Hello friends, welcome to my channel. Let's have a look at problem 270, closest binary search tree value. So this video actually is a revisit of this easy but interesting problem. So first I'll read through the short statement of the problem to digest the task, and then we do the analysis and share some codes. First, let's look at the problem statement. Given the root of a binary search tree and a target value, so return the value in the binary search tree that is closest to the target. So here is one example. So the target is 3.7, right? So if we use our intuition to check all the numbers, we found that so this 4 actually is nearest to this 3.714, right? So for the second example, which is very special because the root represents a single node tree, so we need to return the root value 1. So the constraints for this problem are the following. First, the number of nodes in the tree is in the range given by the closed interval 1 and 10 to the power 4. So in particular, so the tree itself is not null, and the number of nodes is bounded above by 10 to the power 4. Secondly, the node value is non-negative, and the target value can be negative, right? So this is the problem statement and constraints. So next, let's look at the thoughts. So here we're going to traverse a an optimal path for the binary search tree. So here the idea is the following. We introduced a variable, let's call it difference, which measures the absolute difference of the node value with the target value. So we use this variable to measure the absolute difference. And then if the root value equals exactly the target, so we just return the target. Then if the root value is larger than the target value, and then we need to traverse to the left subtree, right? So with the hope that there are some ones with near distance. Otherwise, we need to traverse to the right subtree. So we do this recursively, and in between, actually, we can check the different state. So this is our thoughts. So next, let's look at two formats of solution codes. So in the first version, I'm going to write with some redundancy so that we can demonstrate the idea clearly. So first, I'm going to introduce a diff. So first, I'm going to make it float infinity, right? So, and then we can actually choose the original candidate, let's see, the root value, right? So then let's introduce a variable, so called root current. So this is our starting point for the traversal. So we do not need to traverse the whole tree. We just need to traverse a path. So due to the binary search property. So now it's basically the while loop, while current. So what we're going to do, first we get the value for the current node. And then what we're going to do is to check if the value equals target. So in this case, we do not need to do to care anything else. We just need to return target itself. So this is one thing, or we can return the value because they are equal. So this is one case. Another case is that if the root value is larger than the target. So due to the binary search tree, if we go through the right subtree, then the difference becomes even larger, right? So we do not need to look at the right subtree. So we can go to the left. So here is the same. So we want to introduce a temporary variable because the current node value is larger than the target. So the absolute difference is this, right? And then we are going to set this if temp is less than diff, right? So then the diff will be the temp, and the candidate will be the current root value, right? Or the current value. Let's see. We can directly write value. So this is one case. So in this case, after this check, so if the value is larger than target, we need to go to the left subtree. So we're going to set current equals current left. This is one case. Another case is that the root value or the current value is less than the target. So we cannot go to the left subtree because the difference will become larger. So we want to look at the right subtree, right? So in this case, again, same thing. So, but the target is larger, so we can use target minus value, right? So if temp is less than diff, then we're going to set diff equals temp and the candidate to be value. So after the check, so we're going to go to the right subtree. So we are going to set current equals current rate, right? So finally, if we haven't returned anything yet, so we're going to return the candidate. So notice that the candidate is a number, right? So with that said, actually this forms one solution format. So before we make some comments, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. The wrong answer. So here, oh, I see. The return, so what we want to return actually is an integer. So let's return here the value. So now let's check again. Yeah, it passes all the test cases. So this is the one version, right? However, so here the two, this else if block and else block, there are some repetitions. So now I'm going to copy this code and change this one to be version v1, and then I'm going to write with some optimization. So this I just need one and else block. So I'm going to introduce temp equals absolute value of the value minus target, right? Then we can do a check. If temp less than diff, right? So we're going to set the diff to be temp and the candidate to be the value now, right? And then what we're going to do is that, so in the else, within the else block, so we want to check if value is larger than target. So we, in this case, we want to go to the left subtree. So current equals current left. Otherwise, so we're going to go to the right subtree, right? And then we do the return for the candidate. So this actually is a shorter version of the first one. The first one actually emphasizes the logic. The second one emphasizes the readability. So now let's look at the test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case fast. So with that said, I guess that's about it for this revisit. So here, basically, what we want to emphasize is that we need to use the binary search property to do the coding effectively for this easy but interesting problem. So with that said, I guess that's about it for this video. Thank you for your attention.